Today I'm going to have, it's always difficult to follow an MIT professor with a ton of data and an absolutely fascinating discussion, especially when what I'm about to tell you will hopefully be a little bit depressing and hopefully make you think. So I'm going to talk about Skynet. You're going to see some Terminator slides, but it's really why you should worry about aviation and robotics and automation cybersecurity. And I'm going to leave you with three things. Number one, why it's important. Number two, why the traditional methods for securing networks are really insufficient, necessary but insufficient. And number three, why there's a better way. So off we go. This is me. I'm the president of Corpus Analytics. Our firm, our motto is Secure the Sky. Our job is to help firms who are developing products in aviation and robotics and autonomy to develop cyber resilient systems by design. I can tell you more about that. We essentially do three things. We do risk assessments. We actually teach them how to do it, or we can actually do it from the get-go, from the design stage, and that's what we're doing. MIT undergrad, both engineering and Sloan. Went to a couple other places. That's me with 10 to the Beaver. And I used to fly this airplane. Let me see here. I gotta make sure I'm laser safe there. That's the B2. That's actually me in it. That's my last sortie in the B2 about 3 years ago now. One of the things that's interesting about the B2 is that in 1995, I could have a mission in this aircraft where the airplane was essentially autonomous for all of the flight, with the exception of takeoff and landing. 2 years after I left the program, we solved the landing issue because we put a radar altimeter and we could zero out the altitude error. But everything else would have been autonomous. 2 humans in there, but they're basically playing cards. We do not have a solitaire screen, by the way, but although some people think we do. How terrifying would it be if that all of a sudden went rogue? And I want you to sit back, because everybody here is thinking, oh, you know, we talk about cyber. After a long career in the military, one of the more interesting and depressing things that I did was have to learn to think like the bad guys. And I can tell you one thing, none of the bad guys are thinking of going toe-to-toe with us. Rather, they are thinking of taking over things like this and putting them to uses that they were not intended for. And at the time when we were flying this jet in flight test, with the technology we have today, it would border on trivial to actually take these things over. This is what we're trying to prevent. We're trying to prevent your robot, which should look something like this, nice and blue and pretty and helpful to society, to not look like the Terminator or a Skynet drone. That's what we're trying to do. People go, aviation, dude, who cares? It's not a cat dating app. It's not a pharma. It's not a new fintech. Why should I care? Well, it turns out there's almost 12 million people that are employed in the aerospace industry, in aviation in the US. That's 1.5 trillion with a T. So that's a couple of days spending of the federal budget. 5.4% of GDP. This does not include R&D. So if you include aviation, aerospace and defense R&D, that number actually climbs up to almost 8% of GDP, which is not a number to sneeze at. Now imagine if that were put at risk, and that's what we're trying to prevent. So this is the map of the skies the day that the terrorists launched from Boston around the time on 9/11. Okay? Typical morning in the US. This is right as the first aircraft hit. And this is what the skies looked like when all of those jets and the United States, the airspace over the United States was shut down, which had never happened before. Those of you who were around for this, remember that up until 2008, when we had the financial meltdown, this was the single biggest economic impact to the nation. Now, it was done with some very determined and deadly actors that flew flying bombs, more on that later, into iconic landmarks of our nation. But what if you could do that from a keyboard? Well, Noel, you're crazy, because we really can't do that. Well, have you heard of NextGen? Anyone? FAA's NextGen? FAA NextGen essentially says, we're not building any more lands, we're not building any more airspace, so we have to use and maximize and put as many airplanes as we possibly can into the airspace that we currently do have. And we have to make it very, somebody's trying to hack me. And we're trying to be as effective and efficient as we can in the entire value chain from the time you get on your Uber and get to the airport to the time you actually pick your baggage and come home. That includes decreased vertical separation, horizontal separation, increased congestion in terminal areas, and decreased separation on landing. A bunch of, aviation, fighter guy stuff that basically says the next jet that's going to be filled with fuel is going to be a lot closer to you than you previously thought. In systems assessments and in flight testing jets, this is how we look at these vehicles. Nice little blue, pretty airplane. And we draw an information boundary around it. And then we go, what goes into and out of that system's boundary? This is, top Joe Bag of Donuts, dirt farmer information theory. And it turns out your average airplane has a lot of things impinging through that, very few of them which are secured. 10 years ago, if we would have said, well, those could be used for nefarious purposes, you'd be laughed out of the room. But now we go, that's not outside of the realm of the possible. As a matter of fact, it's well within the realm of the definitely will happen. I'm not going to say any more about the attacks on 9/11. I'm sure not going to put pictures of the explosions, but I will call your attention to something that should make you nervous. If you go to the deep, ugly corners of the web, people will say, oh, the 9/11 attacks were a hoax because there's no way that jet fuel can actually burn or melt metal. I'm here to tell you, after having dropped these things in my career, this is a fuel-air explosive, and it's essentially atomized gas that's then ignited, and it has the power just short of a nuclear weapon. As a matter of fact, in our arsenal, the only weapons that are second in power to nuclear weapons are these. That's why the towers came down, and to make you a little bit nervous, that's what's flying overhead right now. Okay? A bunch of fuel-air explosives that if you manage to get into their flight control or their mission planning or their scheduling or their navigation or corrupt their GPS or any number of attack vectors, they could have equally disastrous consequences. I hope I'm getting your attention. Now, a lot of you will say, well, Noel, you're crazy because what's the probability of that? Let's talk about risk for just a little bit. Everybody knows probability times consequence. Yay. In cyber, we actually look at probability as the combination of vulnerability and threat. So if you have a vulnerability and somebody has a threat that can be mapped to that, then we kind of say you're at risk. And some people say, well, you really actually have to put intent in there because, if you're a nice person, nobody's going to attack you. Or if you're bad enough, nobody's going to attack you. So intent is actually something that's there. One of the things that we're finding out is that in cyber risk, it's the probability of a bad occurrence is essentially 1. So risk management in cyber, especially in systems-based cybersecurity, is less about how do I manage whether something will happen, but it's more managing the outcome of a certainty. And your investments now directly parallel what damage, not possibility, not probability, you want to buy down on the far end. Smart folks, and I count among them some of our clients, are actually taking this approach. What do these companies have in common? They have all been hacked. Everything from a site that caters to adultery, to casinos, to GitHub is actually one of my favorite ones, entertainment, all in the last 18 months. And what was interesting is that in many cases, the impact wasn't monetary. So people were saying, well, we don't need to protect us because who is going to attack us? If anybody saw The Dark Knight and remembers Alfred, Batman's butler, he had a great quote. Some people just want to see the world burn. So you need to assume that somewhere in the billions of people are out in the world who have access to a computer, there's somebody who just wants to cause bad things to happen. If you don't have that really bad feeling mindset, you're behind the power curve. And that is unfortunately a reality of our society today, of our global society. When you combine that with the fact that the more we spend on cybersecurity, the less effective we are, you get this giant melting pot of badness. Okay? And this is where we are right now. And this is my favorite and my only chart in the whole presentation from George Mason, but I love it because it basically says the more we spend, the worse we are. So this is the third point. We have got to do something better. We are spending money like a drunk sailor on cybersecurity, and all we find out is that we get more and more hacks and more exploits. And somewhere along the line, we just sit back and go, well, that's just the state of the art. Well, when you have a bunch of flying bombs on top of you, you can't just sit back and say, this is just the state of the art. When you have robotics and Internet of Things that are completely independent and autonomous all around you, you could not just sit back and say, this is just the way things go. We need to do better. This is not an advertisement for my firm. This is hopefully removing your appetite for lunch. Okay? But I think you can have your cake and eat it too. The reason why I use a cake is because we use the oft misnomer of baking in cybersecurity, which is really a really terrible way to put it, but allow me to explain. Now this is, I lied, there's one more chart. This is notional data based on a lot of projects that actually my team and I have done, and in full disclosure, many of these were before we actually started the firm. Okay, so it's actually the reason why we started the firm. You have a program, Joe Bag of Donuts program, some hardware, software development. It's going to last 20 months. Okay, right here, and by the way, I'm a little colorblind, so hopefully that's purple, is cybersecurity effectiveness, which means that if you spend money up front, you are going to have a very effective cybersecurity campaign. But the more you wait, the less effective it will be. But if you start it early, it actually costs almost nothing because you're doing things at design level. Whereas if you wait, that just inexorably climbs up. What does that mean? The more you wait, the more expensive it's going to be to make your system cyber secure, and the more it's going to cost you. Okay? The less effective your cybersecurity is going to be, the more it's going to cost you, and now that has an impact on your market and your shareholders and a number of things. My current favorite client, and I know we don't have favorite clients, but that's okay, is a startup in Boston, in Cambridge. And they basically said, we're an IoT. They're developing this really awesome IoT sensor. And has tremendous potential. But they were smart enough to realize, Internet of Things, they were smart enough to realize that if they do not take actions to design in cybersecurity, they are going to be just like every other IoT firm out there. They will be indistinguishable in the market, and more importantly, they have a ton of risk. So they actually came in and said, we know nothing about this. Can you help us design our system to be cyber secure? And I showed them this, and I said, dude, you're smart. Now, they're actually not in, I wish they were in month one. They're actually a little further along. That's okay. I think there's a lot of maneuver space. The COO, a very experienced guy with a couple exits, actually said, I've actually done the analysis, and we almost even know what the cost of this is. And they're essentially putting it in percentage of Series A funding, which I thought was actually rather sophisticated. But they are smart enough to get it. And I think they're going to do exceedingly well. If there's nothing else that you take from this discussion, and if you're in any sort of development, I'd like you to take away just one massive takeaway. You have to assume that your system is insecure. And if you do nothing else, when you leave here, go talk to your dev team and tell them you need to bring somebody who's external to our organization. I'd love for it to be me, but it doesn't have to be. Okay? We need to bring somebody external to the organization who actually goes beyond mere checklist running for cybersecurity and help us design from the ground up. Because if you do, it's not a matter of when, it's a matter of how bad it will be for you on the outside. What we want to do is prevent the future generation of robots from looking like this, and instead be happy with robots like that. Okay? That's the end of my prepared remarks. So if you have comments, questions, or suggestions, please let me know. Thanks. And I'm open for a discussion. Go ahead.
So, specific to aircraft, you know, you're as vulnerable as your connectivity in many ways, right? And
Yes.
so, is it considered critical infrastructure? I mean, the way you secure nuclear power plants and the way you secure things in the military are different than the way you secure typical IoT kind of devices. Is there any kind of movement to kind of move aircraft over to maybe more of a military or more of a critical infrastructure type of an environment?
Great question, and let me actually not push back, but pull that thread on what's your perception on the military versus commercial on how they protect systems from cyber threats?
Stronger, not perfect?
That the military is?
Yeah.
Okay. Why do you say that?
Less access, less accessibility?
Okay. So there's access controls and everything.
Yeah,
You know, the PDI, PR. You would be surprised, and this is probably even worse for your appetite for lunch. You would actually be surprised at how porous that is. And the reason why it is because we essentially adapted NIST standards for military standards, and we have taken an approach of, well, let's just run the checklist. But that cost-benefit slide that I showed you, the military is actually, in many cases, and I know this because I managed all those teams, are far on the right. One of the guys, when I was discussing this effort with a startup that I was talking about, is actually my lead programmer. He's the guy who essentially sequences all these actions. He goes, "This is awesome. This is our opportunity to do it right." And I go, "Jeff, I know you and I worked for a long time, but I'm trying to think, how many times did we actually inject ourselves this early in the process?" And we just had this really long, pregnant, awful pause. Realize it's not happening. So there's a perception out there that says we have NIST and all that all of a sudden we're cybersecurity. The reality is that people are just applying these things willy-nilly. What you end up finding is that a lot of companies are spending a ton of money on cybersecurity tools. They have no idea what they're doing. And then they're surprised when they still get exploits done against them. And you go, our first question normally is, what is your system supposed to do? And I have not had a single client who is able to answer that question successfully at the first go. Jim?
Wow, okay. So I just was at NEPO, which is the top 50 NGOs with the top 20 technology companies. We were talking a lot about this. So on one side, we're trying to do exactly what you said, combining NIST and ISO 27000, building a 331-point checklist, which means we're screwed. Is there the Cisco guys with a team of 700 are talking about securing the network as a piece of the solution? Is there some way we can go about sequencing our security needs as a user of technology? I understand your point about a vendor creating a device into it.
So I think there is, but let me use an example. And this is the oft-used castle example. The state of cybersecurity right now is that you have a castle and you want your archers to shoot. Actually, you have a castle and you just have a castle, okay? And then cybersecurity is essentially about keeping people outside of your castle, all right? Systems theory that we use for this, and it's based on some ugly experience. So this is not just pie in the sky, this is unfortunate lessons learned. It means that the model has to be turned on its head a little bit. And the model should go something like this. You have a castle, but tell me why you built the castle in the first place. Tell me what the castle is supposed to do. And then what we're going to do is we're going to help you design into your castle a number of things so that if there's people inside the castle, you can still do your mission. So you basically don't care if there are people inside your castle, because one of the things that we're finding out is that it is almost impossible to keep everybody outside of the castle. And when you do that, your mission actually suffers. The objective of the organization and that enterprise system actually suffers. So by turning this on its head, it's a lot of people are really uncomfortable with it because they go, wait a second, let me get this straight. We're gonna have somebody in our network? I go, they're there now. You just don't know about it. And people go, that's impossible. I go, okay, has anybody ever hacked into Amazon?
Sure.
Yes. Are you going to buy Black Friday deals on Amazon? Yes. Is my credit card at risk? And the answer is, well, yeah, there's a non-zero risk there, but it's actually very tiny. And there's a number of really good reasons why you do that. You can actually have, it's not mutually exclusive, to have a system, an organizational objective, be able to be successfully followed with people inside your system. And that's actually what happened. You got a question?
Yeah, so obviously there's lots of vulnerabilities on both sides, so just focusing on the private sector, who's investing more in cybersecurity? Is it the plane manufacturers or the airlines? And if it's the airlines, how are they differentiating themselves?
I love that question, and I'm gonna go politically correct here for a little bit. So about 4 or 5 months ago, Senator Markey from Mass drove legislation for the aviation industry to report cybersecurity incidents. And I said, wow, this is awesome. Have you guys heard about this? Some of you may have. So I thought it was great, because now we have a legal background, which is actually what the insurance industry needs to actually be able to properly price risk, because now there's some framework to it. So I talked to this delegation. I go, hey, my name is Noel. We do this kind of stuff. Love it. However I can help. What drove you to do this, by the way? And this guy, I won't mention his name. He goes, oh, it was great. We put out a data call to all the airlines and said, can you tell us about your cybersecurity challenges? And the overwhelming response from them was, we don't have any cybersecurity problems.
Wow.
And everybody just went, you have defense in depth. You stuck your head so far down in the sand that you have no idea what's really going on. So at that point they said, okay, we're done talking to you. You have no idea what the actual threat is out there, so now we're gonna legislate it. And that is a long-winded answer to a short question, and the answer is, I don't think the airlines really are taking this as seriously as they need to. The Sabre and the American exploit, the United exploit, were sort of bellwethers. An interesting one to me was Delta. They lost that power station and all that. Again, thinking like the bad guys. Dude, if I had to do a cyber attack on Delta, just because I want to see the world burn, I wouldn't go to their servers. I'd map out their system and take out a node that prevents them from doing it. So a power attack is actually a cybersecurity attack, which goes to, we are now finding ourselves increasingly in the business of critical infrastructure, because critical infrastructure maps topologically very well, to aviation. You have legacy systems with a bunch of open air gaps, a number of things, legacy systems with highly networked systems, and that mishmash has a ton of apertures they can exploit.
Really interesting stuff. Your focus, at least part of the presentation, was on people, hacking into big machines like planes and doing bad things just because they want to see the world burn. But recently, there's been a pretty big rise in doing bad things for for really meaningful economic gain, right?
Yes.
And so ransomware is like the perfect distributable network business that worked really well on the evil side, right? Do you guys do much work on the side of the business that's focused on direct economic gain? And if so, are there some major differences in how we ought to be thinking about this?
I'm going to turn that question on its side just a tiny bit. And I would say that the first question we ask clients is, what is your system or enterprise supposed to do? And we actually have a pretty structured methodology to actually get through that. I wish I would have had one more slide. It's essentially, at the top right, you have system objectives, which is what is your enterprise system, your organization, your whatever is supposed to do, which in many cases is very amorphous. And then on the bottom left, you have essentially component technology. And the art is, it's really, I wish it was like more secret sauce in this, but the art is essentially tying every action you take to what your system objectives are and the architecture of that system. So the reason I'm turning that question on its head is because I would ask, to make this truly effective, I would say, is part of your objective preventing that type of attack? Is part of your objective actually protecting that type of value?
Absolutely.
So, which it is,
Yeah.
but in many cases it's an afterthought.
Okay.
And that's a fundamental issue. If you do that, you go back to that curve where you go, okay, now we can mitigate it, but it's going to cost a lot, because had we actually had that as a system, and I talk system including organization, objective early on, you probably design it completely different.
Yeah.
And what we find out is that, you know, the half-life of cybersecurity tools is now less than 18 months. So we're essentially an analyzer, not a provider, so we're a tool broker. Because, you know, what I see time and time and time again is that the tools that we thought 2 years ago were going to be the end-all be-all to everything have essentially been overcome by events for a number of reasons. And what we call the OODA loop, the observe, orient, decide, act loop of the adversary is incredibly tight. And if you are unable to keep up with that response, you're done. So the art is in, I have my objectives. I know I have to take some architecture, some design steps, but I also have to take some proactive expense steps to actually support that. If you try to patch it in after the fact, then it becomes very, very expensive. I don't know if did I answer the question?
In part.
Yeah.
Last
Yes.
question. Go ahead.
I keep thinking about your graph where the spending increase in security maps to the increase in incidents, meaning it's ineffective. We have dozens of companies in this area who make cybersecurity stuff that got a lot of that money.
Yeah.
Does that mean their stuff is completely ineffective?
Nope.
Is it badly applied, or what's the
I think
deal?
it's poorly applied. I think it's, you know, the analog is, I got a check engine light, so I'm gonna go to the car dealer and buy 4 new tires. They go, why are you buying 4 new tires? My check engine light is on, so I need to spend some money. We have seen, and this is not everybody, because there are some very, very sophisticated firms out there and some very sophisticated players. Mostly we see them in the middle market. They've gone through the throes of, I need to save every penny I can during product development. Now they're actually trying to grow the market and they're actually thinking heavily about this. What we normally see is that cybersecurity expenditures have absolutely nothing to do with the objective of the organization. They're just, it's a silo, a cylinder of excellence that the CISO or the CIO deals with, and nobody actually maps those. At the implementation stage, which is far on the right, on the other slide I have, to corporate objectives. They just go, hey, you know, our competitor did 2-factor authentication, so we're gonna do that. Hey, our competitor had some, you know, insider threat tool, so we're gonna do that. In the meantime, they're still hemorrhaging money, and sometimes they don't even know that, where the right answer is, let's sit back, take an adult-sized look at what your objectives are, and the first question is gonna be, what's the objective of your organization? And we know you're gonna fail when we ask you that question, and then we build on that, and from that we go, you know, you were spending $100 on cybersecurity tools. What we see, and this is not strict data, this is just, you know, apocryphal. If you spend $65 on cybersecurity, 65 of those are ill spent. We've seen that time and time again. You only really needed to spend about 35, and out of that 65 that you were spending, what we really should have spent is about 20 bucks of that in making some organizational process changes. And then you should have spent a little bit of no cost things in policy, and no policy has cost, but you get the point. So there's the way to solve this challenge is far better. Obviously this is a third rail, because now you go out there, hey, you know, I'm Noel, and I'm going to significantly reduce the number of tools that anybody has to use. I'd be, you know, thrown out of the, voted off the island. But unfortunately, that's what we see in systems. I'll hang around afterwards for questions. Thanks a lot for your time and your interest, and I
Thank
hope
you,
that was
everyone.
productive.
Thank you.